Variation will be the last video of this series in this chapter, and we're going to talk about variation. We're going to look at there's three types: direct variation, inverse variation, and joint variation. And if you're familiar with doing proportion problems, this is another way of kind of writing a proportion problem with a direct variation. But if you think of, if somebody ever says, y varies directly as x, I write it as y equals kx. So in any variation problem, we always have a constant of variation or constant of proportionality. And this k right here is actually going to be in every single one, so equals k. But when we say y varies directly, think of directly across. Y varies directly as x. So you read from left to right. Y varies directly as x. That's how I would write that. An example of like a real life direct variation would be something like considering you have an hourly job, so your earnings vary directly as the number of hours you work. As the number of hours you work increase, your earnings increase. So E equals KH. Earnings equals your hourly rate, which is your constant of variation constant, which is not going to change. It doesn't change, so this would remain constant. That's why we say it's constant in this problem. And then the H is going to be the hours that you work. So inverse variation then is just going to be the opposite. It's actually y varies inversely as x can actually be written y equals k over x. So you're dividing by x. So k is still the constant of variation. An example of that would be like thinking of like something like a sound of a telephone ringing and the distance between you and the phone. So if the phone is ringing, the closer you are, the louder it is. But the farther your distance is, or the larger your distance, the softer the sound. So as your distance increases, the sound decreases, and vice versa. So I would actually write that as S equals K over D. Sound varies inversely as the distance. And so that would be a real life type of example for inverse variation. As one increases, the other one decreases, and vice versa. Joint variation is just like direct variation, but it's going to include a few more variables, or one more variable. So if I say y varies jointly as x and z, it can just be written like y equals k x z. And so k is the constant of variation constant. And so a real life example, or an example like I'm thinking of right off the bat of joint variation would be the area of a triangle. And so it varies jointly as its base and height. So the variation constant is actually 1/2. We know what that as, but first we may have to go find that. But since we know the area of a triangle is 1/2 base times height, that's never changing. 1/2 is always going to be 1/2, and then that would be an example of joint variation. So in all these problems, the first two that I have set up here on your practice test we're going to run through, they're just setting you up for getting used to solving in a particular way. And then when you get an application problem with this, you'll solve them that way. Basically, you're always going to first write your equation, then by the wording, if it's depending on what it is, then you're going to find your k. They'll give you enough information to find your k. Then you'll just replace k with the number you found, and they'll give you some more information to go find the other variable. And so you'll follow these three steps. So the first thing is, suppose y varies inversely as x. This is example 9 from your chapter 12 practice. If y is 5 when x is 12, so I basically plug in, I first write it varies inversely, so y equals k over x. I plug in 5 for y, 12 for x, solve for k. And multiply by 12 on both sides, k equals 60. So then part B, what is the specific variation equation? Specific variation equation, now that I know what k is, I just replace k with 60. So I write the variation equation, but I write y equals 60 over x. Now they're going to ask me a question like, find y when x is 30. Well, I just replace x with 30, so 60 over 30, which equals 2. That would be an example of an inverse variation. Now let's look at a joint variation. So if I ask you, suppose w varies jointly as y and z. This is number 10 off the practice test. If w is 8 when y is 2 and z is 3, find the constant of variation. So w would equal k, y, z. I'm replacing everything and I'm solving for k. I write it in reduced form. Since it became 8/6, I would reduce that to 4/3. So now my specific variation equation is just going to be W equals 4/3 YZ, because K does not change. Once I find K, it stays put. It's 4/3. It is what it is. It's a constant. So now find W when Y is 12 and Z is -5. Now they're going to ask me to plug that in, so I just plug in 12 for Y and -5 for Z, and W ends up equaling 4/3 times 12 times -5 is -80. So here's an example now of an application problem. It's a direct variation application problem, but you're following those 3 steps as you solve these. So if I ask you an application problem, you just go through this same process. So the number of Boone and Crockett bucks harvested for a given area varies directly as the number of hunters. If 64 hunters harvested 4 Boone and Crockett bucks, how many Boone and Crockett bucks would be harvested with 320 hunters? You may recognize that as a proportion and set it up proportionally, but if we were setting it up with the variation equation, since it's direct variation, I would write this as, I'm going to use B for bucks, or Boone and Crockett bucks, and H for hunters. So I would say B equals KH, since it varies directly. Then I would replace 4 for my Boone and Crockett bucks and 64 for number of hunters, and I would solve for K, and I end up getting 1/16 when I reduce that. So really my variation equation, my specific variation equation, is B equals 1/16 H. Now they're asking the question, how many Boone and Crockett bucks will be harvested with 320 hunters? I plug in 320 for H, and I solve, and I get 20 Boone and Crockett bucks.